Hello, today's lesson is on solving equations with variables on both sides. So that means we're going to have a variable like x on both sides of the equal sign. Just like in this example right here, 3x minus 5 equals 2x plus 20. So we've already should know the basics of solving equations and doing the opposite operation to eliminate a number or variable from one side or the other. We're going to work with trying to deal with equations that have variables on both sides like this. So whenever we have an equation where there's a variable on both sides, the first thing I want you doing is trying to move those variables to one side, either the left side or the right side, it doesn't matter, but we're going to try to move those to one side or the other. Think of an equation, as usual, like a balance scale. So if we were trying to balance, or a seesaw kind of thing, where we want to keep what's on the right side equal in weight to what's on the left side. If I want to use this as an example, just talking about the x's, I have 3 unknown values of x on the left side, plus a negative 5. Sorry, let me see if I can put that a little bit better. Plus a negative 5 value. On the right side of the scale, I have 2 x values plus a large 20 weight. If we think of this as weights, we have like a negative 5 weight and a 20 weight. In order to compare what an x actually is, the easiest way is to physically remove x's from one side or the other. If I remove 2 of these x's from the right side, then all of a sudden my weight's going to tip because the left side's much heavier. I've taken weight off. If I remove these 2 on the right side, I also would want to remove these 2 on the left side to keep it balanced. So by taking away 2 x's from both sides, the weight should be the same. I should be keeping the same weight on the right and the left side. I've equally removed the same amount of weight from both sides. So if we think of an equation like this kind of a scale, the proper thing to do first in the equation is to subtract 2 x's from both sides. Notice we're not just subtracting 2. It's not a constant 2 that we're subtracting. We're physically removing 2 of these x's so that 2 x's minus 2 x's on the right side completely will cancel out. And on the left side, I started with 3 x's and I took away 2 x's. So just like on this scale, I have 1 x remaining on the left side. Everything else just kind of gets brought down. I still have minus 5. I haven't done anything with that. And I still have this positive 20. Just the 2 x's are canceled. Now I just have the x on one side of the equation. So now I can solve it like normal. I don't have to write the 1x, by the way. We could have just written x minus 5. That would be fine. The 1x is optional. Now, really, we just have a 1 step because there's only 1x left. So to get rid of this negative 5, we're going to add 5 to both sides because a minus 5 and a plus 5 will cancel out. And we get that x equals 25. And we're done because we've isolated x. So let's try that with a couple more examples. Let's look at this problem now. We have x's on both sides. We actually have 2 x's on the left side. So before you start moving x's around, we should combine like terms if we can on one side. When we're on the same side of the equal sign, like in this case, I'm on the left side of the equal sign, you want to combine like terms. That's what it's called. We're just simply adding or subtracting like we normally do. A negative 8x plus a 7x is equal to a negative 1x. That's all we're doing since they're on the same side. We're not doing opposite operations or anything like that because we're not trying to cancel out an x. We're just trying to combine them together. Instead of writing it as 2 separate terms, a negative 8x and a positive 7x, we're trying to combine those 2 together. Now on the right side, I can't combine like terms because 2x and 4 are not like terms, so I just leave that alone for now. Now at this point, I can't combine like terms anymore. So now I want to get my x's on the same side. You need to move the x's over first. I realize that sometimes people want to move the 4 or the 1 over, so they might do this, subtract 4 from both sides. That would cancel out the 4s, or they might want to subtract 1 from both sides, and that would cancel out the 1. I don't want you doing that first. It's better in the long run if you start off by getting the x's together before you start canceling out anything else. So in this case, you do have options. You could either add 1x to both sides, and if you did that, the 1x's would cancel here, and you'd have negative 2x plus 1x would leave you with negative 1x, and you still have plus 4. The other option is to try to cancel out the negative 2x. They'll both give you the same answer. We'll do this one to finish off the problem. So if I wanted to cancel out the negative 2x on the right side, I would add 2x's to both sides. It's not adding 2 again, you're adding 2x's, because having a negative 2x's and then adding a positive 2x's will cancel out. Then what I have on the left side is 1. Negative 1 plus 2 is positive 1x. Again, putting the 1 is optional. These 2x's have canceled out. The only thing left is a positive 4 on the right side. So now I basically have 1 plus x equals 4, and I only have one step left to do. I can cancel out that 1 to get x by itself, and I'm canceling out the 1 because that's what's in my way to get x by itself. X is all by itself except for this 1 right here, so that's what I want to cancel out. And then I actually do this combining like terms on the right side. 4 minus 1 is 3, and x is by itself, so I'm done. Okay, let's try it with 2 more examples. Okay, this one has a little bit more to it. On the left-hand side, I don't have any like terms to combine. There's nothing I can do on the left side for now, so I'm just going to leave that alone. But on the right side, I need to do some work before I can move variables over. So what I want to do first is distribute. Whenever you see parentheses and a number being multiplied by those parentheses, that's when you do the process of distributing. We're going to distribute a negative 4, notice how I circled the negative with the 4, to the m and the 7 that are inside the parentheses. That means I'm going to multiply the m and the 7 by negative 4. This negative 3, nothing's happening to it right now. Then I distribute. Once I distribute, and I'm multiplying negative 4 by the m and the 7, I don't need the parentheses, so the parentheses drop off. You've done that process. Now I still have one more thing to do on the right-hand side here. I need to combine like terms because I see I have 2 like terms that I can combine. The negative 3 and the negative 28 are constants. That means I can combine them together. So I'm going to rewrite the problem. But I'm going to combine these 2 together. And it doesn't matter if you put the negative 4m first or if you put the negative 31 first, as long as they both have a minus or a negative sign in front of them. Okay, so now I've done all the distributing and combining like terms. That's the only thing you might have to do on each side before you start moving the variables together. So now I'm looking at having negative 7m and negative 4m on opposite sides of the equal sign. When they're on opposite sides, that's when we have to start thinking, do the opposite operation. So I can get rid of these by either adding 7m to both sides. That would cancel out the 7m's on the left side. Or I can add 4m to both sides. But I do need to deal with the variables before I start adding or subtracting the 22 or the 31. Move the variables over first. So we're going to do it this way. I'm going to add 4m to both sides. That's going to cancel out the 4m's on the right side. On the left side, I'm still going to have a negative 22. But now I'm going to combine like terms. So I have a negative 7m plus a positive 4m is a negative 3m. On the right side, the 4m's canceled. The only thing left is this negative 31. Don't forget that it's a negative 31 because it has a minus sign in front of it. Whatever symbol's in front of a number stays with it. Okay, and now I can start solving like normal. It looks kind of like a 2-step equation right here. So we need to move this 22 over first by adding 22 because it's a negative 22. So to cancel out a negative 22, we add a positive 22. This just gets dropped down and we rewrite the equation each time. We do this addition right here. That's going to be negative 9. And then we're going to divide by -3 as our last step to get m by itself. -9 divided by -3 is +3, and I'm done. Okay, let's do this with one more example just to make sure we understand it. All right, in this example, I have some distributing to do on both sides before I start moving variables around. So let's distribute and see if we need to combine like terms. In this case right here, we're distributing a negative. If you want, you can put a 1 in front of it and act like you're distributing a -1 to both the n and the -8. We are not distributing 5 or -5. That's not what's being multiplied. The only thing we're distributing here is kind of like distributing a minus sign or subtraction. But you can put the 1 and think of it as distributing a -1. What it's going to do is change the signs, because a -1 in, and then a -1 times a -8 would give you a +8. On the right side, I'm distributing a 2, so I'm going to go ahead and multiply the 2 by the -3 and the n. So it's just going to be -6 minus 2n. Now, on the left side, I have to combine like terms before I go any further, because I have like terms to combine. I want you to distribute and combine like terms before you start moving variables over. So that'll give me a +3, and then I still have -n. There's nothing to combine on the right side because -6 and 2n are not like terms. All right, at this point, now I need to start moving variables over. So do not deal with the 3 and 6 yet. We're adding n, or we're adding 2n to both sides in order to cancel out the variables from one side. All right, this side I'm going to add an n. If you need to, put a 1 in front of that n. That is a 1n that we're adding to both sides. So having a -1n plus 1n on the left will cancel out, leaving just a 3 on the left side. On the right side, I still have this -6. But now I have -2 plus 1 is -1n. Writing the -1 is optional. You could just say -n and that would be fine too. So now I really just have one step here, and that's to get rid of this 6 so that the n is by itself. So I'm going to add 6 to both sides. I'm going to have a 9 on the left and a -1n on the right. Just for emphasis, I'm leaving the -1 on the n for now, because I'm not quite done. In order to be done, we would have to have n equals something, some number. I don't have that. What I have is a -1n, so I have to finish this by dividing both sides by -1. I need to make that n positive, basically. So a -1 divided by a -1 would give me that positive n, and then 9 divided by -1 is -9. So that answer is n equals -9. Okay, so that's how you solve equations that have variables on both sides. The key takeaway here is make sure that you move the variables over before the constant terms. So deal with it by getting those variables together on one side of the equation first.